Welcome, everyone. So today, we're going to dive into a concept that I think truly bridges the gap between pure calculus and the modern corner office. We're talking about integration. And look, let's forget the abstract theory just for a moment. I want you to start thinking of this as a brand new lens for seeing your business, a way to move from obsessing over a single day's performance to really understanding an entire quarter's success. It's an incredibly powerful tool, and I promise by the end of our talk today, you'll see exactly how it can transform financial planning.
So here's our roadmap for today. We're going to start with a simple, really intuitive analogy to get our bearings. From there, we'll get into the actual mechanics and see how we can visualize what integration is, well, what it's actually doing. Now, the most exciting part, for me anyway, is where we translate the math directly into business strategy. We're going to work through a real-world revenue scenario, and I'll even point out some of the common traps you'll want to sidestep. Sound good? Let's get started.
All right, first things first. Let's ground this whole idea in something we all know inside and out: driving a car. Now, it might seem a little unrelated at first, but trust me on this, your car's dashboard holds a surprisingly powerful key to understanding exactly what we're talking about today. I want you to picture your car's dashboard. You've got two key instruments right there, the speedometer and the odometer. You probably look at them all the time without thinking about it, but what you're really looking at is the core essence of differentiation versus integration. They're both describing the exact same trip, but they're telling you two very different and equally important stories about that journey. So let's look at the speedometer first. What is it really telling you? It's not telling you how far you've gone, right? It's telling you how fast you're going right this second, at this precise instant. That's a rate of change. And in the language of calculus, that is your derivative. It's a perfect snapshot of a single moment in time.
Okay, now glance over at the odometer. Its job is completely different. The odometer couldn't care less how fast you were going at any single moment. Its entire purpose is to add it all up. It accumulates every single foot, every single mile of your journey, and it gives you one single number, the total distance. That process, that act of summing up all those little moments to get the grand total, that is integration.
So we've got our core idea. The speedometer gives us the rate, and the odometer gives us the total. Now let's put on our mathematician hats for a moment and formalize this. Because understanding the formal definition is what's going to allow us to take this simple car analogy and apply it to some very complex business problems. And here it is. Simply put, integration is the reverse of differentiation. If differentiation is all about breaking a total down into its rate of change, like figuring out your instantaneous speed from your journey's total distance, then integration is about rebuilding. It takes all of those individual speed readings, all those rates of change, and it pieces them back together to tell you the full story, the total distance you traveled. This inverse relationship is really the secret weapon here.
Okay, so an odometer is simple enough to read. But in business, we don't have a nice little dial for total revenue or total profit. So, how do we actually see this process of accumulation? Well, this is where the visual power of calculus comes in, with a concept that's both elegant and incredibly useful.
I want you to imagine a graph of your company's daily revenue for, say, an entire month. The line on the graph goes up on good days, it dips down on slower days. Now, what if I told you that the total revenue for that entire month is represented by the physical, measurable area underneath that squiggly line, between day 1 and day 30? That is precisely what integration calculates for us. It finds that exact area. Now, this right here, this is the crucial question for any of you in this room. Why on earth should a future business leader care about some geometric area on a graph? This isn't an art class. What does this area actually mean? For our balance sheet, for our strategic planning, for our shareholders? Well, as it turns out, the answer is everything. And this is where it gets really good. This is where we translate the abstract language of calculus into the concrete decision-making language of business. This is the bridge that takes us from the textbook right into the boardroom. Okay, look at this slide. This right here is your Rosetta Stone. This is where it all clicks into place. On the left, you have the language of mathematics. That rate of change function we talked about, in business, that's your marginal cost or your marginal revenue, the cost or revenue from producing just one more unit. It's useful, but managers need the big picture. So we perform an integration. We find the antiderivative. And just like that, we're not talking about marginals anymore. We're talking about total cost and total revenue. And that abstract idea of the area under the curve, that's not a geometric shape anymore. It is your total accumulated profit for the entire fiscal quarter.
This is how a mathematical concept becomes one of the most important key performance indicators you'll ever use.
All right, that's enough theory. Let's put you in the manager's seat for a minute. We are going to walk through a scenario where you have to use this exact tool to make a critical forecast for your company. This is where the math really meets the money. So, here's the situation. You're the manager. Your research and development team hands you this function, R prime of t. They tell you this formula predicts the rate of new revenue your product will generate each month. Now that's useful, sure, but the board of directors, they don't care about the rate in month 3. They have one question and one question only. What's the total revenue we can expect in the first 6 months? They are asking for an accumulation, a grand total, and what they've just given you is a classic integration problem.
So how do we get them their answer? We follow this exact 5-step process. First, we identify the rate function they gave us. Then, we set up our problem. We tell the math what we want to know by setting up something called a definite integral. We set the boundaries, our limits, from our starting point, time 0, to our endpoint, month 6. Step 3 is the real core of the calculus. We find the antiderivative of that rate function. This is the amazing step that transforms our rate of revenue function into a total revenue function. Now for step 4. We use that new total revenue function. We plug in our endpoint, 6 months, to see the total revenue at that point. Then we plug in our starting point, 0, and we subtract it. This process is called the fundamental theorem of calculus, and it's what gives us the net change over that period. And finally, step 5, the number that comes out of that calculation isn't just a math answer, it is your total projected revenue. It's the number you take to the board. It's the number that dictates budgets and sets investor expectations.
Now, this tool is incredibly powerful, but as with any powerful tool, there is potential for error. Before you run off and start applying this, I want to show you the most common pitfalls I see students make year after year. Getting this right is all about precision, so let's make sure you know exactly what to watch out for.
Please take a good look at these and burn them into your memory. Forgetting the plus C, the constant of integration when you're building a general cost model? That's not a small mistake. It means your entire model is fundamentally flawed from the very beginning. A simple calculation error when you're evaluating the bounds, that could be the difference between a projection that's off by $10 or $10 million. And maybe the most dangerous of all, misinterpreting your units. If your calculation gives you a rate of, say, $50,000 a month, but you report it as a total of $50,000, you could bankrupt an entire department. You must always, always ask yourself, is my final answer telling me how fast or how much? The difference is everything.
So, what is the ultimate takeaway here? It's this. Integration is not just a calculation, it's a storytelling tool. It lets you tell the story of accumulation, of growth, of the total journey your business has taken over a period of time. The final number it gives you isn't just data, it's the climax of that story. So I'll leave you with this final thought. We've talked about total revenue and total cost, but what about the total carbon emissions over a decade? Or the total market share gained over a product's entire life cycle? The area under the curve can tell countless stories. Your job as future business leaders is to find the right curves to look at.